Okay, chemistry. Let's do a thing. I feel like it's been a minute, and then I thought about it a little more. It's because it has been a minute. We did a lab and we did review and we did a quiz, and it's been a little while since we've been back in the notes. Don't worry, it won't be long until we're back doing another lab. But until then, right, in the meantime, we got to learn some new stuff. Where I am in the notes, I've actually skipped quite a bit ahead. I'm on page 34. And I know that the last time we did stuff was all the way back on page 30. And you might be thinking, well, what happened to 31 to 33, Kalimlim? Why are we just skipping around? The reason we're skipping around is because 31, 32, and 33 are all just review questions. They're all just stuff to practice. Will we come back to it? Yeah, of course, absolutely. I'll want you guys to do more practice before the next test, before the midterm. So I'll use those pages as examples of questions that you can do, a practice that you can do to remember how to do specific things. But in the meantime, we are here on page 34, and we're talking about atomic mass. And you might be like, again, Kalimlim, what the heck? We've talked about atomic mass. It's on the periodic table. What else do we need to know? Not a ton more, but this is the explanation as to why the atomic mass on the periodic table is not an exact value. It's that like weird decimal place, right? So what we can do is we can measure, and that is an enormous pen tip. I don't need that to happen. We can measure the atomic mass of atoms by way of comparison with something that we call the standard mass, right? There is actually a chemistry standard for what the mass of atoms and molecules are. The standard mass is considered exactly to be the mass of a neutral atom of carbon-12. You remember, we talked about that notation with isotopes. Name dash number means it's that element with that exact mass, so carbon-12. Which means that the standard mass is 12 atomic mass units. Now, AMU stands for atomic mass units. You also might see just a lowercase u. They mean the same thing. One atomic mass unit, or 1 U, is the exact mass of one proton, or one neutron, and we define it as exactly 1/12 of the mass of a carbon-12 atom. Again, capital C is the symbol for carbon, dash 12 means the same thing. But we know that not every carbon is carbon-12. We have carbon-13 and we have carbon-14, which means that we know about the existence of isotopes. So what we need to do in order to calculate an atomic mass, it's actually an average. The atomic mass is, and it's not just an average, it's a weighted average. What I mean by a weighted average, it's kind of like your grades on your report card, right? The grades on your report card, not all your classes count for the same amount of credit. This happens in college too. Some classes are weighted a little more heavily than others, right? So your PE class, gym class, is actually weighted as only half a class because you meet half of the week. Honors classes are weighted a little more heavily. AP classes are weighted even more heavily. Typical classes are 1 credit. If you have a half-year elective, it might be count as 0.5 of a credit, and then you'd have the other 0.5 of a credit for the other half of the year. But it's a weighted average. Specifically, it's a weighted average of all the naturally occurring isotopes. So this phrasing is like the textbook definition for what is the atomic mass. Well, it's a weighted average of all the masses of all naturally occurring isotopes of an element. All right. So I've underlined naturally occurring isotopes down that way to kind of remind you to kind of be wary of that. Sorry, thought I was shedding for a second. Shedding hair. Just to remind you of that wording, of that phrasing, and be like, okay, I know what that phrasing means. It means that they want me to do an average atomic mass. Now, in order to determine like the weight that each isotope carries, we need to look at something called the percent abundance. There are no notes to take here, however, there's an equation. I'm going to talk more about that in a moment. But the percent abundance tells us what portion of the atomic mass comes from which isotope. Specifically, it tells us what percentage of that element in nature is found as that particular isotope. So skipping over this for a second, looking at the example, the abundance of the isotope sodium-23, Na23, is 70%. 70% of naturally occurring sodium is sodium-23. 10% is sodium-24, 20% is sodium-22. The reason we need these percent abundances compared with the actual masses is because there is an equation, right? So this equation here, I'll try to box it in, right? This equation here is the first and I believe only example of an equation that you need to be able to do and to use without having a backup copy on the reference table, right? And I'm going to make like an adjustment and alteration because throughout class today, students were constantly saying that this is a complicated version. I agree, this is a complicated version. We have this percent, and then it says etc. because if you have more than two isotopes, you need to continue to add them together. So percentage times mass of isotope A plus the percentage times mass of isotope B plus the percentage times mass of isotope C, and so on for however many isotopes you have, all divided by 100, or make the percentages into decimals and do not divide by 100. Right? I'm going to set it up both ways here. I'm going to use this table of information, right? And I'm going to set this up. So determine the average atomic mass of sodium. Well, that's 70% times 23.01 plus 10% times 24.30 plus 20% times 21.98. Take all that divided by 100, or I could do 0.70. So 70% as a decimal is 0.70 times 23.01 plus 0.10 times 24.3 plus 0.20 times 21.98. And if I do either of these, I'm going to get 20... I did this a few times today, so you'd think I'd remember the answer. But fortunately, I have a calculator. And my calculator says... why does that look wrong? That's why it looks wrong. There we go. Yeah, that's right. Okay. Sorry, I would recognize the answer from doing it a few times a day. But the answer here is 22.93. And that's what I end up getting, 22.93, no matter which way I do it. Right? The atomic mass is oh my goodness. One day I'll be able to write. This atomic mass seems closest to Na23 because its abundance is highest. Right? This isotope has a 70% abundance, so it should make sense that my final answer should be closest to sodium-23. Also, my answer should be close to the masses that I have. These are all 20-something. My answer is 20-something. It's something that you can do to check yourself, right? There is one more example. Nope, there it is. Determine the average atomic mass of chlorine, of Cl. Right? So again, they give me the table. They have to give you the table. They have to give you the information about the percent abundances and the masses and what the different isotopes are. That way you can do the math and compare. So if I do this, I'm going to have 0.8 times 35.3 plus 0.15 times 32.85 plus 0.05 times 31 remember, you take the decimal place and move it over 2 places to the left. When I do this, I get 34 point, I think it was 7, I think it's 7.2. I'm going to do the math. I'm going to make sure. So, 0.8 times 0.3 plus 0.15 times 32.85 plus 0.05 times 31. 34.72. Again, what is it closest to? It's closest to Cl35 because it has the highest abundance. One day, spelling will be a thing that I can do. Alright. Now, this is not a super difficult thing, but it can be a little tedious, right? Just recognizing it. We will get into the formula mass, and we will get into, over here, percent composition on B-Day. It's a tomorrow problem. In the meantime, I have set up a few questions from the Orange book, your Orange review book, which you totally remember exists, right? But that Orange review book has a few questions. I've listed them as an assignment on my CBA. Look for your Orange book. If you can't find it, I do also have pictures of the questions up attached to the assignment, all right? What my plan is, finish these notes, right? Finish page, the rest of 35 here, finish page 37 and, 38-ish. But finish those pages on Wednesday, on B-Day. On C-Day, we'll start a lab. On D-Day, I want to have a quiz just on these pages, so 34 out to 38, right? Just so that you can plan ahead a little bit. I'd like to do basically 2 labs and 2 quizzes before the Christmas vacation. I think we can get there. And then there will be a review test after the vacation, but before the midterm. It's basically going to be a good review for the midterm, right? If you have questions, if you're a little stuck on doing this, I'd recommend try the questions first. If you're super stuck, either bring the questions in during class the next time you're in school, or send me an email if you're a fully remote student. I will do my best to explain it. If I have to, we'll set up a meeting so we can talk about it. But I will see you in the next video, which will show up on B-Day. Until then, kids, take care of yourselves.